Ah yes, quite a difficult question this one. Number 13, it's well worth a look. So we're told that we add 2 grams of an acid, we dissolve it in water and make it up to 250 millilitres. A sample of that, 20 millilitres, required a certain amount of sodium hydroxide for complete neutralization. If 1 mole of the acid can release 3 moles of hydrogen ions, they ask you to calculate the relative molecular mass of the acid. Now the first sort of thing to do with this type of problem is to write an equation, but we're not told what kind of acid it is. Notice how we had other problems like this with indicators. We'd call the conjugate base of the acid A, and we'd write H in front of it to indicate it's an acid. This question indicates that there are 3 moles of hydrogen ions that the acid can release. So we could represent this acid as H3A. Once we do that, we can write an equation. Okay, there's our equation, H3A. So now we can say this is what is happening. 3 moles of sodium hydroxide react with every 1 mole of acid to give 3 water and trisodium acid, if you like. Easy. So far. Now we've got an equation, we can actually start to work through the work that we need to do. The first thing we need to do is to figure out how much sodium hydroxide we used. I'm just going to cut from something that I prepared a little bit earlier. Okay, so we go back up to here and I will just explain it for you. Okay, how much sodium hydroxide did we use? We're told 24.3 millilitres or 0.024 litres of a concentration of 0.103 molar. Okay, we know that this, if we can convert this to moles, we can say that we've got number of moles equals concentration times volume, which is comes out to be 2.5 times 10 to minus 3 moles of sodium hydroxide. Now we know that for every 3 moles of this, we get 1 mole of that. So we could actually figure out how many moles of acid that we have. That's pretty much straightforward. Let's have a look at that just here. Okay, so the number of moles of acid is equal to 1, which is our target, divided by 3, the thing we're comparing it, moles of sodium hydroxide, which is equal to 2.503 times 10 to the minus 3, divided by a third times a third, which is 8.34 times 10 to the minus 4 moles. So now we have got moles of acid. We know the number of moles of acid that we have. Okay, now we need to get mass. If we're going to calculate the molecular mass, we know that molecular mass equals moles divided by mass. That's year 10 stuff. That's the old story. Now we've got moles. How do we get the mass? Well, we look at how much of that 2 grams we added. We know that 20 millilitres of in that 250 millilitres there was 2 grams. We took only a fraction of that, 20 divided by 250. So mass equals 20 divided by 250 millilitres times the total mass that we had, which is 2 grams. And this works out to be 1.6 times 10 to the minus 1. And that is how many grams that we actually have of our acid. How did we do that again? Just looking at that again, we figured that we had in total 2 grams and 250 millilitres. So we only took 20 millilitres of that, so we've got to have some fraction of that too. That is 20 divided by 2. Hey, even my mixing isn't that bad. You know, assuming it's all properly mixed, and it would be. This calculation shows how much you get. Okay, so now we've got mass equals moles per mass. We just substitute. MR, the molar mass, equals moles. This many moles of acid divided by this many grams. Sorry, other way around. Sorry, mass equals mass per mole. Sorry, this many grams divided by this many moles. Okay, fairly straightforward one to do in that particular case. Okay, and that works out to be 191.8 grams per mole. Hey, using titration, you've just determined the relative molecular mass of the substance. That's a rather useful and powerful technique, one that chemists love because it allows you, once you've done that, makes it easier to identify the substance. And that is how to do number 13. Lucky number 13. Hope you enjoyed it.